Welcome back to my channel, and today I will be showing you the prototype for my steam turbine. I've already 3D printed most of it, and I'm going to explain why I chose the radial turbine instead of the axial turbine that most steam power plants use. First, let's look at the coupler for the shaft and the turbine. It's just a flange with some bits on it, just so the screw isn't the thing holding all the forces. Then to the shaft, that little cutout will not be there on the final shaft because it's a weak point. Here's the coupler I ordered from a Chinese website. It's actually pretty good quality. I haven't ordered it in stainless, just mild steel. There you can see the threads of a M6. The surface finish and everything is quite smooth. Just the time it took to get here was a little long. This is the spacer that gets sandwiched between the ball bearing seat and the turbine housing. It's just so the turbine sits more flush into the housing, so it doesn't stick into it and take away space. This is the ball bearing seat. It has threads in it, so you can sandwich the spacer between it and bolt it to the turbine housing. The bearing is a standard bearing with the inner diameter of 10 millimeters. Outer is 26 millimeters, and it's like capped on both sides. Next is the turbine cover. There you can see I thinned out the layers so it would print faster and use less filament, but it's high quality. The first one I made too short, so the turbine didn't really spin. This is the star of the show, the turbine itself. There you can see the cutouts for the radius on the connector. The turbine blades. The print quality is a little bad, but that's because of the filament. It's old filament and it's all kind of on the spool the wrong way, so it stopped printing sometimes midway through. I designed this freehand. I just kind of eyeballed it, and I hope it works. I mean, I took inspiration from my exhaust side turbo. This is the turbine housing, where the ball bearing seat with the spacer bolt onto, with some flat head screws. This is the backside. The cutout is there so you can position the spacer better. You can see the little groove on the side. That's just so the steam can flow better. And if you put everything together, you get a semi-completed steam turbine. You start the assembly by putting the connector to the shaft with some screws. You can see I only put 2 screws in because just for showing off purposes it's enough. I somehow managed to thread it directly into the 3D print. Next up is the putting the connector and the turbine together. I don't have a screw for this yet, but it works. You can see the print quality in the turbine is really bad, but I already ordered new filament and it's already here. In the next step, we're going to put a spacer and the ball bearing on the turbine housing. Just have to kind of line up these holes, and then we put the screws in. And don't worry, in the finished turbine there won't be any loose or missing screws. This is just for testing and seeing if it all fits together. I think it looks good. This is again the same filament. This is where the flange from the shaft is going to sit. Then you just kind of push the shaft through the bearing. It's a little difficult because it got mangled when I put it into my drill. There you have it. There you have it. The spinning turbine. You can move it by hand. The bearing works quite nicely. This is the wrong direction. Not the one direction it is supposed to be going. And then afterwards you just have to put on the cover, and now to the steam nozzle. This is 3D printed metal. I ordered it from another Chinese website. My hopes is that the steam picks up some more velocity before it hits the turbine. I have to model the mount for this to the turbine. It obviously needs to be tight and with already two separate pieces bolted together, and then making this sealed against these two will be a design challenge. If you have a simpler idea, let me know. And when I designed this, it's basically ready for testing. Then the last step is just putting on the cover. It is still a little bit difficult to turn the turbine because the turbine is pretty warped from 3D printing. I will just order the CNC version of it if you guys think it's a good design. If you have any tips or would do it differently, just write it in the comments, and don't forget to subscribe and like. And now, why did I choose the radial turbine instead of the axial turbine? I chose the radial turbine over the axial turbine because I think the radial turbine fits this purpose better. It's not as complicated as an axial turbine. It's more space efficient, but it's more difficult to stack. Well, kind of stack these multiple of these together from the radial turbine. The axial turbine is more difficult to manufacture because, of course, it's the bearings are in line with the steam that's coming through. So yeah, I just kind of went with the radial turbine. There's plenty of videos on it. All of these DIY steam turbines are made with radial engines, so I just thought, well, it's the way to go. In the future we can certainly try to build the axial turbine, but for now a radial turbine will have to do. If you don't know the differences between an axial and a radial turbine, just ask me in the comments. And if you want, I could also make a separate video explaining the difference between these two. If you actually made it to the end, made it through this torture, I would like to thank you for watching the whole video. Share your thoughts in the comments. Leave a like and subscribe if you want to, it would really help me out. And as always, may many great ideas cross your mind.